So what we're going to actually do today is there's the hands-on 4 started up, and we're going to go through the goofy way in which Panos or Palo Alto does NAT. The way our Juniper SRX does it is pretty common. Like if I roll the dice, you're probably going to have a Cisco firewall someday in your life. That is going to be, with the exception of the interface being blue and HTML driven. With Cisco, it'll be green and Java. But aside from that, the buttons are going to basically be the same. They're very similar configurations. Palo's is very different. And actually, even like pfSense is very similar to Junos and Cisco. It just labels stuff differently. Palo Alto is very, very different in how it does stuff. So that's where we're going to take a look at this today. This will be a precursor. We will not have class on Thursday. So I'm going to be in Minnesota visiting a high school, doing some fun stuff. So on Thursday, we will have a new lab come open, which will, if you notice, everything we've been doing has been with an MSP machine or MSP network, and you're like, why did you label all these VMs as the same town or city? So our lab will open up, and we will have an MSP and Chicago VMs. So you'll have your Chicago company and your Minneapolis company. One of them will have a Palo Alto firewall, one of them will have an SRX, one of them will use NAT, and one of them won't. And we need to enable communication between them. As a heads up, the Palo Alto one will not be using NAT, because the way it does NAT is stupid. That's my technical term for it. It's just as goofy and weird, and I disagree with how it does it. So, and not necessarily saying I'm right of everything in the world, but its way of doing it is really weird. Even Palo Alto is like, yeah, it's different. And then they kind of stare at their feet when you accuse the engineers of doing it in a dumb way. So, either way, we'll still get to see the experience of this. So, starting off, I'm going to be cheating a little bit because I already ran my VMs through moving stuff over, because we are still going to play around with the fun ways of doing that. So, to get started, we need to log into your interface, which for you guys, not having switched it over, I believe should be there. And it's at that IP address because, does Palo use in-band or out-of-band management interfaces? No, well, what was the difference between in-band and out-of-band?
One of them uses the first port as an in, and then on the second it sends out for your interface.
Yeah.
Connect.
So like one of them with in-band, you would just access the firewall over the interface that it's doing routing on. So you would just go to your default gateway and access it. Whereas with Palo, is this our default gateway? A .2 address? I mean, it could be, but it would be a really dumb one, wouldn't it?
Yeah.
So, we have out-of-band management, which is why it's just a weird interface to log in on. But is this coming up for folks? Is it 142? It is 242? Make sure you're doing HTTPS. The Palo interface will not open up if you don't do HTTPS. It won't redirect you or anything, it just drops the packet. Or we could do it through the command line, which will work for everyone. Should we just do that instead?
Okay.
Or did you get it to open? No go? Alright. So I'll show you both ways, how about that, of going in and switching. Because if we're going to switch this over to use NAT, we need to change the IP address. Because right now our LAN network is handing out public IP addresses, and we don't want that, right? That would be very expensive. Not to say we couldn't do it, but it would be quite expensive. So either way, log in, admin in the command line, or admin in the GUI. Admin. So We'll get logged into that, and I'm going to be scrolling around, which drives me crazy to do, but I'll do that. So from the command line, if we go into configure mode, from the web interface, if you go over to device, and once you're in device, make sure you're in the setup along the side. Yours might be defaulting to the licenses configuration down at the bottom, so go to setup and come over to management interface settings. Hit the gear and delete out the 64 address in there and change it to that. If you're rocking command line, we need to delete device config system IP address. That will remove the old IP, whereas if you're doing the GUI, you can use the clever backspace key. And I'll write the IP on the board so you can see it. So we'll delete that. Where'd my mouse go? Here it is. Then from command line, we'll go set device config system IP address 192.168.1.2 net mask 255.255.255.0. Hit enter and commit. Type commit, or if you're in the web GUI, hit OK and then hit the commit button up in the upper corner. If you're doing it through the web interface, what's going to happen when you hit commit now? Yeah, you're going to have problems because your computer is configured to be on a 6443 something something address. The device it's talking to just left the network, so to speak, right? It's gone. It's not going to be able to talk to that anymore.
It's admin.
Yep. Lowercase. Did you reboot it? Oh, so if you rebooted it, it would have just still be starting up. As you're going along committing, yeah, it's going to be going, and it's going to like have compiled the config and be ready to apply it to the ASIC, and then it's going to go to apply it, and then it'll be at like 70-some% when it's like, all right, making sure it applied successfully, and then the web interface is going to be stuck. So it's going to try to do another like AJAX request. So in the end, if you're doing it through the web interface, it's going to totally just die out on you eventually. So what's your next step? So navigate, but before you do that, what do you need to do?
Restart.
No? Change your IP address. There we go. So on your admin machine, you need to go change the IP address to be, I don't know, something on that subnet. I would do something clever like .100. That's just how I roll. So, any questions on getting that moved around? Did you get it reset through the command line? Still working on it? Okay. I don't want to leave you behind. Or if it's easier to read, I can put the command up on the bigger screen. Like delete device tab system IP dash tab. Is 1.0 a valid IP address on a subnet mask of slant 24? It's not. Yeah. In the actual management interface, you don't know, you can just leave default gateway empty. Then we do set device, I think it's device config, system. See, I'm even typing tab as I'm typing this.
default gateway be 192.168.1.2?
No. Your default, oh, sorry, I thought you were asking on the management interface. When you go to switch around your actual computer, what you would do is, yeah, put it at like 1.100. Then we're going to give it the default gateway address of 1.1. That doesn't exist yet. Sorry, I thought you were asking about the management interface. That's why I'm like, yeah, you don't need one. But in this case, we will need one because we will be
That's what I was asking.
tinkering around. Yeah. So we'll set an IP in there. I'm having little notes scattered all over here. Where I personally get to the IP config settings in Windows, I hate going through the Windows stupid GUI and crap like that. So I go run and do control net connections, and that just opens you straight to the network adapters. Just as a pro tip, if you get super duper annoyed. Back in the days of Windows XP, you could just right click on the adapter down here and hit properties, but Microsoft determined that that was far too easy. So they buried in a bunch of GUI, and then that's when I learned that. So once you get that set, you should be able to browse to 192.168.1.2 and get to your firewall. I'm not quite sure what all I will have done to mine. Whoops. Make sure mine loads up. Yeah, you're going to get a new certificate error because it's a self-signed certificate, and it's going to be very offended at that, or Firefox will be. And our next stop is going to be the network tab. Once again, it's like a cooking show. Like, all right, set your IP addresses, and then there's a little animation on the screen. All right, our IP addresses are set now. Kind of like, bake this for 30 minutes. So since we're switching this over to be a NATed network, we need to set new IP addresses. So we want the actual default gateway address that we are using on our LAN here to be 192.168.1.1. So double click on the Ethernet 1, wait for it to load up, go over to your IP4 tab, enter the new address. Same thing going on with the Ethernet 2 for our DMZ interface. Do we need to change the WAN interface address if we're switching to NAT? Why or why not? Do we need to switch the WAN interface's IP address? Why not? Because we want a public IP. Yeah, so everything's NATed inside, so we still want the public IP address. So I'm going to do this on slightly bigger font, just so you are able to see it. Those are the two things we need to change. So with our IP addresses configured, when we start to look over at policies, I deleted, there was a policy in here. I got rid of it. Because it's one that we either created in class, or if you did the lab, you'd have some policies and stuff in there. If we go to NAT, that should be blank right now because our firewall is just routing packets, like a router. So what we're going to do next is go through the Palo Alto adventure. Normally, when we look at NAT, what three kinds of NAT were there? There's static. What's static do? Yeah, it can be one-to-one. So we could do one address to one address like so, or we could do like one subnet to one subnet, or depending on your firewall, you could actually do one range to one range. Like, you can do all sorts of stuff. Or you could have something weird like 100 going to 109. Like, they don't have to correlate really in any way. But it's one IP address, link them together. So static NAT. Static NAT's fairly universal everywhere. The Palo does not have a button. Like, when it comes down to this, the Palo box does not have a button that differentiates between any of these. So what was our other two types? Source and destination. Where would we use source NAT, or why would we use it? Other way. Traffic going out. So when we think about traffic going out to the internet, do we know where it came from? Yeah. Yeah, because we should be running the network, right? So we should know it came from this subnet because I made it, right? So that's source NAT. Source NAT is used by your house. It's used by businesses, small, big, and huge. They all use source NAT because they don't want to have to give a public IP address to every internal device. So instead of giving, say you've got 10,000 computers, instead of having 10,000 public IPs, we have 6 or 10 or something, right? Something like that. Or in the case of your house, you have 10 devices and one IP. So that's what source is used for. What was destination then used for? Yeah, that's where we're hosting a server and we have outside traffic coming in. When we're hosting something out on the internet, do we know where the traffic is coming from? Generally not, no. There are weird instances where maybe we do, but usually not. Especially if it's just the internet. If it's like this business and this business, well then maybe. But when it's the internet, we don't have the slightest idea where it's coming from. But we do know where it's going to, because it's going to our box. So that's where we have destination NAT. The way Palo Alto does it, that is at first kind of, the actual configuration is kind of cool, but their processing order is a little off. Or not off, like it's not wrong, it works, but it's weird. So in most of our firewalls, what do we evaluate first, NAT or firewall? No, it's the other way. First thing we do when the packet comes in, we run through NAT, then we hand it over to firewalling. So what that means is our firewall rules on most devices are going to look like the internet as a source is going to 192.168. something something. Now, in all actuality, is the internet, is a packet from the internet ever going to have that as a destination? Because it could never get there, right? So the firewall is dependent on the NAT process handling it. The Palo Alto is different. It sorta is doing them both at the same time, which is weird and kind of confusing. But what is cool, if you go to policies and then NAT, when this loads up, I mean, this part is wild and exciting, right? We give it a name. We'll go DNAT server 1. Saying, hey, we're going to do destination NAT for the server. We're going to host this website now. The next stage, and this is kind of where like, there's our categories, source, destination, and static. They apply, but the way this like interface does it is goofy. Instead of doing like a specific source NAT rule, destination rule, whatever, these are all fall into the same category. And the way they do it is we basically write a search filter, sort of. I mean, it's not like a filter as in we're doing regexes today. The firewall does that for us. But we say, like, we want to find packets that match this criteria. So when we look at original packet, what we're specifying is, like, we want to make a NAT rule that applies to packets that met this criteria. Which, if you think about when we made the source NAT or the destination NAT rules before, we were doing that, but the direction was kind of already implied. So in the case of this, Our source zone, what's our source zone going to be? When we look at the list. If we're doing destination NAT from the internet to the server. It's untrusted because that's our internet zone, right? It's coming from out there. This is the next weird part, is in the original packet that we received, the source zone was the internet because it came from the WAN interface. What was the destination zone on the original packet? It's also untrusted. Because in the original untampered packet, before we do NAT, the packet came from, originated, and was destined to the same place. It was destined to our interface on the untrust zone. That's kind of weird, though, because in the logic of all the other firewalls, we look at like, we're doing destination NAT, and the packet's going from here to here. Whereas here we're saying, well, it came from this zone, and the address it's going to is on the same zone as well, and that's goofy. So that's the weirdness of how Palo does this. The next part, it's like we can actually even specify the exact interface that this applies to. But we're not going to worry about that, so you can leave that blank. Or now that I've clicked it, it's going to be any. And then the next one's going to ask us is, what is the original packet's port? So this is saying when it comes in from the internet, is it on port 80, the destination of the port? And that's what it's asking, is the destination port. Even though it's just asking us a service, that's what it's really asking for, is a destination port of the packet. Do we know a source address?
No.
That we don't know. Do we know a destination address? Yeah. The destination address is going to be what? Is it though? So we're thinking original packet still.
Oh, then it was.
It's going to be our public address.
Yeah.
That's on the WAN interface, which in this case is 24.220.181.102. That is the destination that we see. So this is where like this next part makes a little bit more sense. So we've met the criteria of here's the packets we're looking for. Now when we translate them, we're saying, okay, we did the find, now we're going to do the replace. Now you notice two words that appear, source and destination NAT. So technically the Palo doesn't necessarily have static NAT. To do static NAT, it would be a source and it would take two rules to create that, which is goofy. But that's the magic of using different vendors and truly like understanding how NAT works, right? So in our case, if we're allowing something out from the internet to go to our server, is it source or destination NAT? What part in here, what's the one thing we knew for sure? We knew the destination. Do we know a source address? No. So when we come over here, and this is also where I find it funny, like this type is none, this type you have to have a checkbox to set it to something, right? There's just weird like quirkinesses of it. So our translated address, what do we want to rewrite this packet to say as the destination address? Now we would do server 1. With the caveat being we need to go update the server 1 to have a NATed IP now. But that's what we would set it to. Here's the next one that's kind of goofy. Over here when we're looking at the original packet, we want to do port 80, which this is labeled as a service called HTTP. When we're talking about NAT and doing destination NAT, now it's a port. It's not a service anymore. So it's not great, right? For the IP6 world, this firewall works great because you never do NAT. But we hit OK on that, and this has now made a somewhat quirky IP address or NAT rule for us. kind of understand what the boxes were that we were going through and like why it's sort of weird. The other thing we need to check now is going over to the address objects and make sure we have server 1 set to be the proper IP. And what's the last thing we need to do for this? Well, we have to commit. We have to set the actual server's IP address too. So yeah, I'll quick commit that guy, and we go into our server 1. Same story as before. We need to come in here and change around. Two items right here we go. So again, I cheated, but control net connections, or actually in servers it has the server manager GUI. So you go to local server, click on this, and it will open the adapter properties for you as well. We go in here and set it like so. Then life should be good. I'll put over here in my text document real quick. Server like so. So config committed. Will this work yet? Doesn't work quite yet, because even though we have natted the traffic, we never made a rule to allow it through. So we've done some stuff to try to rewrite the IP and whatnot, but it's still not quite there. So over in security policy, we need to add a new rule. Should be allow untrust DMZ server 1 is what I would call that, I guess. That's, again, we talked about naming conventions before. That's my style. When I log into DSU's firewall and they do it differently, I conform rather than being that guy.
Use spaces in the names?
Generally not, no. I don't know in Palo if you can or not. I don't think you can. You can't? That's right, because you couldn't get your config to commit before, couldn't you? So, whatever name, you can call it ASDF for the name, it doesn't really matter. A name of some sort. So, on the source, remember we're thinking firewall rule now. What's our source zone? Still going to be untrusted. Do we know a source address? No, we never did know that. We can skip the user tab and do destination. This is where it's weird. So most devices, when they process NAT, they do all of the natting, then they hand it over. It's like totally disconnected things. So, question of the day, what is our destination zone? So the destination zone now is the server network. So the natting has been done far enough that a new zone is tagged in the packet. That has been done. The destination address then, what would that be?
Why would that be the untrusted?
Normally we would think this should be the 192.168.255.100. In this case, it's still the original destination, like that. So it has remapped the zone to be the new zone, but NAT has not like translated the packet IP address destination yet. So it's allocating, it's like claims that it's efficient in that it allocates a small memory buffer to track the zone, but never rewrites the address of the packet until it gets to the process where it sends it out on the interface. Then it does it at that level instead of just doing it all at once. It's, I don't know, it's their architecture, I guess, and it works. It's just weird. So when we go over to service, that'll be HTTP. Action will be allow. Life is good. Although you should probably make sure that the allow rule is above the deny all rule. That'll help. As weird as it is, that one's still pretty straightforward. The allow's got to be above the denies. So now we shall commit this, and we should be able to browse our web server. The source NAT part of it is way more logical kind of thing than the destination NAT. So I'll show you that real quick, like, as well. Once, I suppose I should make sure this actually worked. Or do you all just trust me? Not hearing anything there. So we'll log into this internet machine. Well, the browser appears to not be caching. Let's close and reopen IE. Just to make sure. Yeah, it's working. So that is our interesting source NAT or destination NAT mechanism inside of the Palo. The other one I'll show you is the source NAT. I said those backwards, didn't I? It's the interesting destination NAT. Now I'm going to show you the source NAT. So this is straightforward. We'll go through this quick, just in the interest of not making anyone's head hurt because of how this is weird. Now I'm even typing it wrong. So this is where, like, if you look in like my Juniper firewall for the IA lab, when you click the source NAT button, you'll notice all of my rules are prefixed with source NAT or SNAT. And you're like, that's dumb because that's all that's ever going to be in there. Whereas here, source and destination NAT rules are going to be intermixed with each other. So it does make sense to label them. So even if the label is kind of redundant, I put it in there anyway. Just also kind of force a habit. What's that? Yeah, statics would also be in here, but statics would be pairs of source and destination, which is like, so sort of, kind of, if you were making a static NAT rule, it would be a source and a destination address translation in the same rule. So yeah, I guess that would be static as well. It's silly though, because you could separate them out as two rules, and then you'll be really confused later on. But to make a source NAT rule for our LAN, this one is more straightforward. Because if we're making a source NAT rule for our inside network going out to the internet, what's the source zone going to be? It'll be our trusted. What will the destination zone going to be? Untrusted. What would the destination zone going to be? No one caught that I'm just failing at grammar today. Do we care about the destination interface? No. And service, we're going to NAT every port going out to the internet. When we look at, do we know the source address? We kind of do. Maybe not a specific address, but we know it would be 192.168.1.0. slant 24. Or you could leave it as any. It depends on like if you had a lot of subnets behind that. I usually do explicitly put each subnet in there anyway, as just kind of a, in case I mistag something later on. It's like a little extra check, and I want my NAT rule to be like as tight or unassuming as possible. Do we know a destination address? No, because it's the internet, right? So when we're talking about the translated packet, our translation type will be static. Oh, well, no, I was wrong. There's a static IP in there. If you're going to do a static rule. But static is under the source translation, which is weird again. So we want to do dynamic IP and port. There are options to where you could leave the ephemeral port numbers the same, but that's going to be weird. So we want to change around the IP and the port. And we can either do a pool, a list of IP addresses in there, if we were a big network and own lots of public IP addresses and have lots of internal stuff. Or we can pick interface address. And then pick the actual WAN interface, which I think is 3. And then choose the address like so. Hit OK. Thus, we have our source NAT rule. Suppose we need to make a security policy for it as well. The security policy should be straightforward because we're not listing IP addresses. So it'd be allow, whoops, trust, untrust. We could do it all by zone. So our source zone is the trusted zone. The destination zone is untrusted. And the service or port should be any. And we'll allow it. And we should make sure that it's in order. There we go. Now we'll commit it. Question?
Yeah, I'm trying to get the response up, and it just isn't going through for me.
So any questions then? The other thing in the Palo is like the monitoring thing is your friend. Nick, do you have a question? No? Okay, cool. So, yeah. With that, oh, I guess I never tested the rule. There's our source NAT rule works because we can ping out to the internet. So with that, on Thursday there will be a lab, but no class or no video. And the lab will basically be a hodgepodge of the 2 labs that we've done in the past. So it'll be fun and leave a smile on everyone's face, right?
We're gonna choose Palo or
The Palo will be for the not natted network, because this was weird. And the Juniper will be used for the natted network. Because I don't have a good way to push that out to you and let you pick one way or the other. So, yeah, you get a little flavor of both. But that's better than making you do NAT with the Palo, because that's goofy, right? So, and that is our way of showing that not all network devices necessarily, although we have similar configs, they can be very, very different, right? So, with that, I'll see everybody later.